Starting with number 12 here. Number 12 is an absolute value function. We know our parent graph of absolute value is 0, 1, 2, 0, 1, 2. And our equation of our parent graph is y equals absolute value of x. Our transformation is a vertical shift down 2. And so what we're going to do to show that vertical shift down 2, we're going to subtract 2. So 0 minus 2, 1 minus 2, 2 minus 2. So our vertex, instead of being 0, 0, it's now 0, negative 2. And then we have the point 1, negative 1, and we have the point 2, 0. We know that absolute value is symmetric. And so that's how I'm going to get these points over there. Our domain is always all real numbers. And our range, what changes our range is where the vertex is. So our lowest y value is negative 2. Our highest y value is infinity. All right, our next one is number 13. And this is an exponential growth. Our parent graph, or our parent function here, is 3 to the x. Okay, so this is the one we're going to do a transformation to. So if we plug in negative 1, it's 1/3. Plug in 0, it's 1. Plug in 1, it's 3. Okay, 3 to the negative first power is 1/3. 3 to the 0 power is 1. 3 to the first is 3. Now what's happening here is we have this 2 out in front, and that's going to give us a vertical stretch of times 2. And here is our parent graph. I didn't write that up down here. So that'll be vertical stretch times 2. So what we're going to do there is multiply all of our y values by 2. This will become 2/3. This will become 2. This will become 6. So when we go to graph a exponential growth or decay, we always have to make sure we're plotting and sketching that horizontal asymptote. It's always the line y equals 0 unless there's a vertical shift up or down. And that's the only way that that'll change. And then we can go ahead and plot our new points. So we have 0, 2. We have 1, 6. And we have negative 1, 2/3. And this is going to go up to infinity. And this is going to approach the asymptote and never cross it. So it's going to get closer and closer to 0. Our domain, again, is all real numbers. And our range starts with our lowest, which is 0, but notice we're not including it. And that's because our graph will never reach that asymptote. It'll just get really, really close to it. All right, and the last one is negative 3 quantity x minus 1 squared. So our parent graph is a quadratic, so that's y equals x squared, or f of x equals x squared. Our parent table, you can just do 0, 0, 1, 1, negative 1, 1. We can also do 2, 4, negative 2, 4 if you want to do more. Transformations, we have 3 things. We have a vertical reflection. And the way we take care of a vertical reflection is we change all of our signs on our y value from positive to negative or negative to positive. And then we have a vertical stretch times 3. So you can then multiply everything by 3. You can do it separately or do it all at once. So if we multiply all of our y values by negative 3, it takes care of the reflection as well as the stretch. And then the last transformation is what's inside, and that's this x minus 1, and that's going to move it horizontally to the right. Remember, we do inverse operations when it's inside. So since the minus 1 is inside, to undo that, we add 1. And when we add 1 to all our x values, that means it's going to be shifted to the right. Domain of a quadratic is always all real numbers, negative infinity to positive. Our range, we want to take a look at our vertex. So let's go ahead and plot this. So our vertex was originally 0, 0, and now it's 1, 0 because of the shift to the right. And then we have 2, negative 3, and we have 0, negative 3. And then the next one is 3, negative 12. So because this is that stretch, that's why we're going off the graph here. But we can definitely show that. Okay, so you can see with your range, your smallest y value is actually negative infinity, and your largest is 0. Oops, and that will be a bracket because our vertex is included in our range.